talking about upgrading to Moshi. So who here has used Gson before? Okay, cool. Almost everybody. This is going to be rather focused on the process and API changes that come along with moving from Gson to Moshi, but there are also going to be a lot of benefits for people who use other JSON serialization libraries. The APIs won't feel too unfamiliar, especially if you already know Okio's types. So Moshi is a JSON serialization library for Java. There are a lot of them. It has a streaming and an object mapping API, just like most of them do. So you can do very high-level operations in your Java applications and your Android applications to map your JSON elements to Java types, objects, maps, lists, etc. So Moshi is also based off of Gson. The point here is that Moshi is kind of Gson 3. It's Gson 2, but kind of Gson light. It takes a lot of the really good parts of Gson's API and borrows those, and then removes a lot of the extra parts of Gson's API that not necessarily a lot of people use or didn't encourage the right design patterns. And so you say, like, why not Gson 3? Why isn't it just Gson 3? There's a lot of internal systems, like at Google and in projects we all work on, that are based on Gson. And the fact is, like, those are just never going to get updated to Gson 3. Even if Gson 3 came out with a breaking API, these systems probably are just never going to get updated. And I'm not really here to, like, advocate that we go update all of our systems to Gson. Like, there's just probably hundreds of millions of lines of code written in Gson, and Gson works fine. We're going to be talking about some of the optimizations, performance optimizations of Moshi over Gson. But I think what we'll really see is that Moshi's API, in more focused API, lets us do, is really the main benefit of updating from Gson. So your code that already works with Gson doesn't necessarily need to be updated. You're not necessarily going to get amazing performance impacts. But really new code here is going to get a lot from using Moshi. So that's why I'm going to be introducing kind of the types and the ways that, as people who've seen Gson's API, can go to Moshi and start using it really fast. So Gson, like I said, is kind of in active development. There are a lot of features, there's a lot of bug fixes that could really go into Gson, but a lot of them would require breaking API changes, and not everybody's going to update. Gson also kind of has this problem of being too lenient. A really great example is like platform types. If you've ever tried to get a type adapter from Gson for a date, if you worked in a non-trivial app, you probably hit the pitfalls of that. You probably run into the default date adapter not doing what you'd expect it to do. Maybe you relied on output stream or something, or some platform class, and the implementation changed in an Android update. And then all of a sudden, your adapter that was relying on those implementation details doesn't work on the new platform. So Moshi actually requires you to register your own custom type adapters for platform types. And we're going to get into that in just a bit. Gson also has a rather large API. It's not quite as large as Jackson or some others, but it has a lot of things like JSON deserializer and other things that don't necessarily encourage the right usage. And And it also has like a whole document level API that Moshi kind of focuses, it kind of takes a more focused approach. It also, Gson 2 does this a lot better than previous versions of Gson, but there's still some inconsistent exceptions. You sometimes get an IO exception when it really should have been some kind of data exception. Moshi keeps it really simple. You just have IO exceptions for IO problems, and you have data exceptions when there's something in the data structure that basically was unexpected from the data that you actually had. This is not really a huge one, but this is like maybe one just if you're trying to convince a platform lead or something. You can take like some kind of hard numbers. Moshi is slightly smaller. The size there is the deck size. And Moshi's size here, actually, I'm not including OKIO, but most of us are already including OKIO in our projects. If you use OKHTTP, Retrofit, you already have OKIO. So really, on top of OKIO, Moshi is only adding 112 kilobytes to your deck size. And then we're going to be covering some of the actual like API niceties as well. So one of the performance optimizations here is if you are already using OKHTTP, then you're already using OKIO, and you can go ahead and share these segment types with Moshi. So instead of with Gson needing to copy over a bunch of data, we can go ahead and share these buffered segments with Moshi out of OKHTTP. Also, excuse me. There's this really handy select name and select string API in JSON Reader, in the streaming API of Moshi. This is kind of built on OKIO's options class. And so you can avoid allocating and just immediately garbage collecting a bunch of strings, especially when you have like a list of objects, and you have to allocate strings for all of these field names, and then you're just basically throwing them out. With the options API, you basically pre-allocated these strings, and then you just select off of the index, and then you don't have to constantly be GCing all these things as you're deserializing. Okay, so now. How do we upgrade? Those are some of like the performance benefits, kind of the history behind Gson. So I'm going to go kind of over some of the APIs that you're most likely to miss or have slightly changed maybe going from Gson to Moshi. The first thing that maybe like most people notice, especially like everybody who uses the object mapping API, is there's no field naming policy. Gson had this API. Again, kind of like a larger API, had an API for field naming policy. This was where you could generally say, I'm gonna have all of my model classes in camel case, but I'm gonna set a field naming policy of kebab case. And so when you're deserializing, just like you're telling Gson, just know that all of these field names are not really camel case, they're actually in kebab case. So there are a lot of problems. Like one, it's kind of just a waste of computer like time. Like it's you could have just typed it out. Two, and probably most importantly, it's bad for search. It's like you say your server guy goes into your Android repo and he's trying to find if anybody uses this field. Well, he doesn't know that you've set a kebab casing. So he's like searching for the dash name and you've typed the capital N name and he doesn't find, the name. So it's really bad for searching. It's bad for readability in that it's much more clear, I would argue, that we actually that we actually name our field names based on the actual data they represent in JSON. So I kind of personally take the approach of defining the field names based on their domain. So in fact, my JSON model would actually be the dash name, or normally in JSON, like we do snake case. So a lot of my my models and my data classes actually just represent the JSON responses in their actual names, rather than using a field name policy or representing the data differently. And so this kind of offends us as Java developers, but as Android developers, I can think of a really good case where we already do this. With layout XML, we define our view IDs typically in snake case already. And that doesn't offend us. Like, even though we're referencing it in Java, in all of our Java classes, we're doing r.id the underscore view. And it's really a signal to us that, hey, this is in a different domain. This lives in XML. So that's why I'd kind of argue that it's helpful as a reminder to remember what domain these models come from. There's a link here by Jesse Wilson. He talks about your strict naming conventions kind of being a liability, why field naming policy doesn't exist, and why you should be more explicit about your naming for your JSON models. So reflective field naming policy does exist. You can take the @serialized name and then basically you're just going to need to convert all those to @JSON. So this is where, again, like, I'd kind of advocate for just naming your fields what they are, but sometimes that's not possible. Like, if your JSON model has default or something as one of the keys, then you're going to need to use @JSON, and because it'll conflict with a Java keyword. But even if you disagree with me, like with naming your actual model keys, what they really are, you can still use this @JSON annotation. And so really that transition is just serialized name to @JSON. Yeah, and like I said, I prefer using the domain's naming convention. So the streaming API, good news, for the most part, it's really the same. You're just going to need to change your imports from JSON reader to Moshi's JSON reader, JSON writer to JSON writer. Moshi, like I said, adds the options API, and also another kind of, these are like two of my favorite things, is the options API and set fail on unknown, both of which we'll get to in just a second. So the options API, like I said, we can go ahead and prepare these keys ahead of time, and then we can read them out directly with the select string or select name APIs. And it just returns in the index that we've given our options. So if I were reading in key 1, I'd get the index of 0, key 2, index of 1. Set fail on unknown is really handy for debugging. Probably you won't use this in actual like production code, because this is a way of basically when you're developing your app and you've got your server developers sending you some model, and you're using, like, say, name, and but really there's a name and there's a last name, but you're not mapping that to anything in your Java model. Then you'll miss out on the last name. So this makes sure that you're actually using all of the things in the response. Or in the JSON model. So basically, it just throws an exception when you try to call a skip value. So there, when you were trying to, when you were basically missing the last name key, you just get an exception and you know about it right away. So it's not really good to use in production, because if your server updates and it adds more data, you'd get an exception and you'd fail deserializing. But for developing, it's really handy. The object mapping API, what's changed? Type adapter is now JSON adapter. Just a little bit of a naming change there, but it acts the same. There's no document level API like Gson from JSON. So this API was kind of asserts that you consume the whole document. Moshi doesn't have an API like that. You just use the JSON adapters. The other thing here is that, a get adapter just moves to adapter. This kind of also encourages you to reuse and cache your adapters. So there's also another blog post here by Jesse, who kind of talks about these reflection machines. So we want to make our adapters more expensive to create, and then they're not expensive to use. So we do as much as we can up front, and then when we actually use them, then they're cheap to deserialize, to serialize with. So this encourages you to actually reuse these adapters rather than basically the Gson from JSON and then needing to pull from Gson's internal cache of adapters. You should actually be reusing your adapter, caching it directly in your application layer. So here's where I said we're going to get into this a little bit later with leniency in Gson. Date is a prime example of this. Most of us who've worked with applications for a while have run into date not doing what we expect. But things like array list, this is what I saw kind of commonly upgrading from Gson to Moshi. A lot of people had array list in their models, but that's a platform type. So you probably just want list here. And again, it's so that we don't rely on the implementation details of array list, and then in a JVM update or an Android update, something changes in array list and you've broken your model. Similarly, Android namespaces are part of platform type. Kotlin, Scala types, etc., are all platform types. The things that aren't really platform types are maps and lists and collections. Those maps are really just what your JSON objects are, and lists are just what your JSON arrays are. So those again don't have implementations. Those are things that you just that adapters do exist already in Moshi for. You don't have to register your own. Object mapping, there's some wrappers here. A lot of these already exist in Gson. They do kind of what they sound like. The things that are new here are indent and fail on unknown. Fail on unknown, again, is just a wrapper, so you can use the JSON reader. Fail on unknown. Indent is so that you can have nice things like pretty printing your JSON, and you can just add as many spaces as you want, or tabs, etc. Then there's no JSON serializer, and there's no JSON deserializer. These required you to buffer the whole object. They didn't work well with the streaming API, so they don't exist. You basically have to update to the JSON adapter, type adapter factories, APIs here instead of using JSON deserializer, again, because it encouraged kind of performance issues. And also just a bigger API and redundant. So the other big thing that I saw kind of caused some confusion when updating from Gson to Moshi was there's no more type token API. You're going to see this a lot with Moshi. It actually encourages using a lot of standard Java APIs. And so we're going to see that in a bit too, but instead of using Gson's whole type token factories, we just use the types class, and it just has a bunch of factory methods to create the types you need. So here's an example, get parameterized. Here's just how we can get a list of strings type. So basically everything you see in type token, there's a factory method in types to use just a regular java.lang.reflect.type for Moshi. And then this was another thing when updating from Gson to Moshi that can be surprising if you don't kind of know maybe some of the underlying pieces. So unknown enums in Gson, we could define, so enums are just strings in your actual JSON, in your JSON objects, in your JSON elements. They're just strings, but in our Java types, we'd like enums. We'd like, the type safety of them. So, but say our server updates, and then we get jog here into our exercise group. In Gson, we would just get null. And so I saw a lot of application code just handling null. So that's not really right. It's kind of extra leniency from Gson that Gson gives us. Moshi does the proper thing, and it throws a JSON data exception when it sees an enum that doesn't map to any of the enums you declared, or it sees a string that doesn't map to any of the enums you declared. But that's kind of awkward for application developers who maybe don't want to fail deserialization. There's not currently an API in Moshi to handle this. You can kind of copy out, I've got a link here that basically just copies the internal enum JSON adapter from Moshi and uses it to have a default value that you can register. So like there's an issue if you have ideas, feedback at all, definitely contribute to the issue on GitHub and submit any ideas you have there. Just like know that this is currently a thing that might surprise you when updating. And JSON qualifier, this is a really, really, really handy thing for people using the object mapping API in Moshi. In Gson, we kind of had we had this API called JSON adapter, which was an annotation, and you would say, okay, this is a special case in my model. I want you to deserialize, in this example, this string differently. So this was kind of awkward because you didn't really know what the precedent rules were. It gets caught up in a lot of other, like, you know, which factory runs first in which order. So not completely on the same level, but for a lot of the same use case, you can now use JSON qualifiers in Moshi. And so you can say, okay, they're just type qualifiers. So, you know, if you use like Dagger, basically, or Java 8's type things, or type annotations, you can say, okay, this is the same type, but I want to handle this slightly differently. So in this case, like we have a wrap string, and we want to say, I need you to like unwrap this so we don't have this layer at our application level. But for all other strings that aren't annotated with wrap string, then just deserialize them as strings. So this is what it would look like in Gson, and then you're going to notice we're going to kind of get into how these JSON adapters work in Moshi, but here's what it would look like in Moshi, so pretty similar there. And we're going to get into like what that from JSON means in just a minute. So you kind of saw there in we kind of had these easier JSON adapters. So this is what it would traditionally look like. You'd have to write out a lot of code for your type adapters. You sometimes have to know if you need delegation. You'd need a factory. You'd have to basically understand the pattern that libraries like Gson, Retrofit, Moshi all use for delegation. And it was a lot of like error-prone code. It was a lot of code that maybe wasn't tested, and it was kind of just a lot of boilerplate. Here, you know, if it wasn't right type, then we need to say we can't handle it by returning null. We need to actually implement all that logic. Here we can just move that logic into this simple object class. And these from JSON to JSON, there's nothing magic happening here. It's just a reflection API. So when you add this object to your Moshi builder, it actually creates this factory for you. Moshi creates this factory for you with reflection, and you pay this really quick upfront cost. And then you're not paying costs. You know, you're not paying extra cost at deserialization time just when adding it. So there's this whole API actually adds a lot more here. You can do more with delegation. You can add a lot of JSON adapter delegates. You can even just if you already know how to deserialize to one type, you can quickly map to another type here, like from JSON bar value, map it to a foo. So again, like so you don't have to write out a lot of boilerplate JSON adapter code. Then more advanced and things that maybe you haven't seen, maybe a lot of maybe has prevented you from updating from Gson in the past. But again, there's this idea like polymorphic types. Some of us have seen. So this is especially true. Like the place I see this at a lot is in lists. So we have a list of animals, but then there's like some key in there that hints us, hey, this type is a dog and it needs to be deserialized a certain type. This type's a cat, it needs to be deserialized a certain other way. But we have this list of animals that we need to deserialize. The only way to know how to deserialize that is to buffer the entire value up front, though. So Moshi now has an API for this, and we're going to look at that in a sec. So here's our examples. We need to deserialize dog differently than we need to deserialize cat, but we need a list of our animals. So this is where I said that Moshi takes the approach of reusing the Java types we already know. So Gson had this whole idea of a JSON element, and then that either contained a JSON object, a JSON array, a string, primitive types. Moshi just uses regular maps, lists, objects, strings, primitives. So those map one-to-one there, as you can see. And so it's a lot more clear, like just what's happening here. So in Gson, you need to go through kind of a little bit of ceremony here. You need to buffer the whole value, get as JSON object, and then you need to use the from JSON tree API to actually go back and reuse the buffered object to delegate to in this instance the cat adapter to deserialize to the actual type we want. In Moshi, the API is on JSON reader. It's called read JSON value. Again, you have to buffer the entire object, and then here we're asserting that it's a map. And then the API instead of from JSON tree is from JSON value. And so this is just your actual type. It's not JSON. It's just your Java type. And then you're going to treat that as like a map or a list or a string or a primitive, and you're going to deserialize it to the type that you actually want. And so that was, this is kind of a lot of like error-prone code. It's code that we like wish we didn't have to write, and hopefully you only have to do like once or twice maybe across your like mid-sized apps. Hopefully, like your API doesn't do your server developers don't do this to you too much. But it is kind of a lot of code. It's kind of error prone. Typically goes untested. So Gson has in the example is a runtime type adapter factory that covers like most of these use cases. It pretty much covered that case that we just handled. Moshi doesn't have anything yet, so like feedback welcome. Again, like comment on GitHub, like or post blog posts. Like basically let us know like what your use cases are, so that the runtime JSON adapter factory or whatever ends up coming out can like be can cover the 90% use case. So this is for developers who actually want to like update from Gson to Moshi in their current app. And so like what does that process go about looking like? Here are like some handy examples or like tips. So in Retrofit, there's this whole idea of converter factory. How many people use Retrofit? Okay, so like pretty much everybody again. So the code's posted. I'll post the slides later, but you can actually this exists in the examples. So this is just a link to the examples. But there's this really handy thing where you can get the type annotations off of your service methods, and so So there's this trick where you can just start annotating your methods with, or your parameters too, with like an annotation that you define. So here I'm saying like, my com.example.moshi, that's just some custom class that just some custom annotation that I've defined. And I say, okay, this is a signal to my converter factory that I just want to annotate, that I just want to deserialize or serialize with Moshi. And then fall back to deserializing and serializing with Gson. So this way you can update piecemeal. You can just say, okay, all new code, start using Moshi, and when I update old code, I'll start annotating it with @Moshi, and then eventually I can get rid of all of this. The other thing I want to point out is like Auto-Value-Moshi exists. So if you use Auto-Value-Gson, pretty similar. You can get your JSON adapters, generates all that. Even easier, you can just have your JSON adapter factory for all of your auto value types, and just remember to add that to your Moshi builder, and all those types are going to work great for you. So here's some resources that I know, like a lot of people follow the Moshi tag, so you try to get back as fast as possible. So any questions, ask there. Also, Jake gave a talk on a few OK libraries. So if you want to dig more into the OKIO types and a lot of how Moshi builds off of those, and how other library and how OKHTP works with it as well. It works with OKIO as well. Follow up there, and then the announcement blog post by Jesse talks. It kind of reiterates those points on the performance and API benefits that you get from moving off Gson and onto Moshi. So that's Moshi.